Hello, and welcome to Learning Outcome 4, Understanding the Tools and Techniques Used for Software Development. In today's session, we will explore why understanding software development tools and techniques is essential in today's fast-paced technological world. This video examines the key tools and methodologies that support every stage of the software development process, from coding and testing to deployment and maintenance. You'll discover how these elements work together to ensure efficiency, quality, and innovation in modern software development. Software development tools streamline the entire lifecycle, from coding to deployment. Text editors and IDEs help in writing and debugging code efficiently. Version control systems manage code changes and collaboration. Build automation tools simplify compiling and testing processes. Testing tools ensure that software functions as expected. Techniques in software development help structure and design software efficiently. Modular programming breaks code into manageable modules. Object-oriented design models real-world entities using classes. Agile methodology focuses on iterative cycles and customer feedback. Version control and collaboration tools facilitate teamwork. Automated testing catches errors early. Development tools boost productivity by speeding up coding and testing. Collaboration tools allow multiple developers to work together seamlessly. Debuggers and test frameworks reduce errors before deployment. Modular approaches enable code reusability across projects. Project management tools provide transparency and track progress effectively. Integrated development environments, or IDEs, bundle essential tools into one interface. They offer code editors with syntax highlighting and auto-completion. Debuggers help test and fix code issues efficiently. Compilers or interpreters run programs seamlessly. Integration with version control and testing tools enhances workflow. Software is developed and tested across various environments to ensure quality. The development environment is where coding begins. Testing environments simulate controlled conditions for thorough testing. Staging environments mirror production setups for final checks. Production environments are live and used by end users. Selecting the right tools can greatly impact a project's success. Automation and CI/CD speed up delivery processes. Testing and debugging tools minimize bugs and errors. Version control facilitates teamwork and project management. Scalability and adaptability are essential when new technologies emerge. The waterfall model is a linear, sequential approach to software development. Each stage must be completed before moving to the next. It's suitable for projects with stable requirements. Advantages include simplicity and clear deliverables. However, it's inflexible to change and may reveal issues late. Agile development is an iterative approach focused on flexibility and feedback. Work is divided into short cycles called sprints. Continuous delivery and adaptation to changes are key features. It encourages teamwork and communication. Agile is ideal for projects with evolving requirements. Scrum is a specific agile methodology for managing complex projects. It employs sprints, daily stand-ups, and defined team roles. The product backlog lists features or user stories. Sprint planning defines tasks for the next sprint. Regular feedback ensures customer satisfaction. DevOps combines development and operations for efficient collaboration. Automation, continuous integration, and delivery are central practices. It enables faster releases and reduces deployment errors. Strong collaboration between teams is essential. DevOps is suitable for large-scale systems requiring frequent deployment. Rapid application development focuses on speed and flexibility. Prototyping and user feedback are prioritized over rigid planning. It involves quick construction and refinement through user input. Fast development cycles and early visibility are advantages. However, it may lead to weak documentation. The spiral model combines Agile's iterative nature with waterfall's structured phases. It emphasizes risk management and repeated refinement. Each cycle includes planning, risk analysis, development, and testing. Suitable for large, high-risk projects, it allows gradual improvement. Expert management is required. Extreme programming focuses on software quality and responsiveness to changes. It uses short cycles, continuous testing, and frequent releases. Practices include pair programming and test-driven development. High code quality and fast feedback are benefits. It's demanding for developers and requires constant user involvement. The prototyping model builds an early working model for user feedback. It helps users visualize the product and reduces misunderstandings. User satisfaction increases as the model is refined. However, it may lead to unrealistic expectations. Poor management can cause delays. Lean development focuses on efficiency and waste reduction. It borrows principles from lean manufacturing. Core principles include eliminating waste and building quality in. It encourages continuous learning and adaptability. Lean is suitable for agile teams working on scalable products. Software development tools support programmers throughout the process. IDEs simplify writing, testing, and debugging code. Version control systems track changes and enable collaboration. Build automation tools streamline compiling and testing. Testing tools ensure code quality and consistency. Testing methodologies verify software performance and quality. Black box testing focuses on functionality without internal knowledge. White box testing examines internal logic and code paths. Gray box testing combines both approaches for balanced coverage. Unit testing verifies individual components for correctness. Deployment techniques deliver software to target environments. Manual deployment involves step-by-step processes by operators. Automated deployment uses scripts and tools for consistency. Continuous deployment releases tested code automatically. Blue-green deployment maintains two environments for minimal downtime. System performance review ensures software operates efficiently. Benchmark testing compares performance against standards. Load testing measures behavior under expected traffic. Stress testing evaluates performance under extreme conditions. Profiling and monitoring tools track resource usage in real time. In conclusion, understanding software development tools and techniques is fundamental to efficient and effective programming. From integrated development environments, IDEs, to deployment methods, each element plays a vital role in ensuring quality, collaboration, and continuous improvement. By effectively integrating these tools and techniques, development teams can create reliable, maintainable, and high-performing software systems that meet organizational and user needs. Thank you for watching this video. If you have any questions, please feel free to send a message via WhatsApp at 07,484,361,688. Thank you for your attention and see you soon.